Today I will discuss about pressure, its units, types, measurement and applications. So, first is the concept or definition of pressure. Pressure is defined as force per unit area. So, pressure is equal to force upon area. Therefore, any object or material having a weight will exert a pressure over the area where the force is acting. So, if a object is having weight or any force which is acting on a body per unit area, that is called pressure. Next is pressure is equal to force upon area. Pressure can be used interferentially to measure other variables such as flow or level. Pressure plays a major role in determining the boiling point of the liquid. So, boiling point depends upon the pressure. Where is the atmospheric pressure? What is the atmospheric pressure at any place? Fluid exert pressure on containing vessel equally and in all directions. So, next slide. Pressure we already defined, force upon area. Each time a gas particle collide with its container, it exerts a tiny force over a tiny area. So, if we talk about the fluid like gases, then each gas particle they collide with the container walls, then each particle will exert a force over a area. So, each particle will exert a pressure on the walls of the container. Sum of all these forces over the area of the container walls, it produces a pressure within the container. So, next we define gas pressure. How are the number of particles and pressure they are related to each other? So, pressure we already know it is force per unit area that particle exerts on the walls of the container. So, gas particle they collide with walls. If more gas particles are there, then there will be more pressure as compared to if there are less number of particles. So, pressure is directly proportional to the number of particles. If more is the number of particles, then more is the pressure of the gases. So, number of particles and pressure they are directly proportional to each other. If we increase the number of particles, then the force acting on the walls it also increases, which increases the pressure on the container by the gases or by the number of particles. So, this is pictorial definition. If number of particles increases, then pressure will automatically increase. So, next is the relation of temperature and pressure. Higher temperature means its velocity is more. If velocity of a particle is more, then kinetic energy is more. And if the volume of the container is constant and amount of gas is also constant, then pressure of the gas is directly proportional to the temperature of a body or a gas. These two things should be constant, like volume and amount of the gas. These two should be constant. So, the pressure of a gas increases with the increase in temperature. If we increase the temperature, then pressure of the gas automatically increases for a constant volume and for the amount of the gas is constant. This is also called this is also called Charles law. If volume is increasing and temperature is also increasing, then that is called Charles law, but here pressure is directly proportional to temperature. So here I have shown a diagram how with the increase in temperature how velocity increases and pressure also increases. If we go from cool to hot, then the particles which are having some velocity v, then the particle kinetic energy increases. If we go from less temperature to more temperature, so if they have more energy, more kinetic energy, then they will collide with the balls with great pressure and more number of times. So hence the pressure increases with increase in temperature. Next slide is how the pressure is generated. We know when a molecule is collide with the wall, then there is some pressure of each gas molecule with the ball, because they are exerting some force on the wall, and momentum we know is mass into velocity. Like here we can I can show here, if a particle is colliding here with mass, suppose its mass is m and velocity is v, if we are supposing that there is no loss of energy from the collision, then the mass into velocity momentum is mv here, but here the direction is changing, so it is minus mv. So total change in momentum from this position to back position is twice of mv. So this is same thing, momentum in one direction is mass into velocity, but the change in momentum is double because the direction is also changing. So in the reversible direction it is minus mv, but the change in momentum is twice of mv. So this is possible only if the collision is isothermal, that is perfectly elastic. If there is no loss of energy from any medium, then this thing can be possible, otherwise velocity can decrease with the collision. So we sum all the collisions over the area to get the force. Next I will define, now we will discuss the units of pressure. So we already know pressure is defined as force per unit area. So force can be in different type of system like pound force, kilogram force, Newton and dyne. This kilogram force is gravitational unit of the force, Newton is SI system unit, and dyne is CJ system unit, and pound force is FPS system unit. So relative to these, if we take area in the same square inches, square feet, square centimeter and square meters, so pressure is equal to force upon area. Force can be in any of the system and area should be in corresponding dash system. So this is the important unit. First is pound per square inches, this is called psi, and second one is kilopascal. Pascal is defined as Newton per square meter. So I will repeat here, Pascal is defined as if the force is in Newton and area is in square meter. So we define Pascal that kilopascal is 1000 Pascal. So pressure is simply force per unit area. Pressure can be measured in different unit depending upon force and area. If the force is in pound force and area is in square inch, then this is called psi. This is the unit of pressure. It is very less used, but it is very important unit. And second is atmospheric or torr. These are different unit of the pressure. We also used millimeter of the mercury. depending upon if we use mercury barometer to measure the pressure. SI system for the pressure is Pascal because force is in Newton and area is in meter square. So 1 Pascal is equal to 1 Newton per square meter. Atmospheric pressure at the sea level is normally 1 atmospheric. This is very important unit in the commercial point of view, as well as if we discuss our according to your syllabus, then this is very important unit. 1 atmospheric is equal to 1.013 into 10 raised to power 5 Pascal, and this is equal to 760 torr, and this is equal to 14.7 psi. So if we want to convert atmospheric into Pascal or Pascal into torr or any other, so we can convert according to these relations. So we can convert one system into another for the pressure. If we know the pressure in atmospheric, we can easily know pressure in Pascal. So SI unit we already discussed, it is Pascal, which is Newton per square meter. So 1 kilopascal is 1000 Pascal because 1 kilo is 1000, Pascal is same. Standard unit for the pressure is 101.3 kilopascal, and it is equal to 1 atmospheric. Here I have written 101.3 kilopascal is equal to 1 atmospheric, and which is equal to 760 millimeter of mercury. This is the height of the mercury column. So depending upon the height we take this number. This is basically the height in the mercury column, and it is equal to 760 torr. So 1 mm of mercury is equal to 1 torr. So this is the same thing, simply repetition of the previous things. 101.3 or 3 to 5 if we want to complete it. Kilopascal, it is equal to 760 mm of mercury, and 1 mm of mercury is 1 torr, so it is equal to 760 torr, and it is equal to 1 atmospheric or 30 inches in mercury, or it is equal to 14.7 psi. So we can use any unit depending upon the requirement of our numerical or the condition we want to solve the pressure. Next is air pressure. Air pressure means because of air. Air is having many gases. So depending upon the gas, the air, different layers of the atmospheric have different pressure because of the different content of air. So our atmospheric is filled with many gases. So mass of the atmospheric above 1 square meter of the earth is 10,000 kilogram, and it is because of the atmospheric gases. This pressure, it can support 76 centimeter of the mercury or about 30 feet of the water. So 1 atmospheric pressure is equal to 76 centimeter of the mercury or 760 mm of mercury. So we define the formula of pressure here. So if we want to find the formula of pressure, we know pressure is equal to force upon area. This is any container in which we put some liquid. For the pressure we want to find, suppose its height is h. So a container filled with a liquid has a pressure because it has some weight. So weight is equivalent to force at a point in the liquid. We know pressure is equal to force upon area. P is pressure where F is force, which is equivalent to weight, and A is area. So pressure is equal to force is equivalent to weight because weight is exerting some force. So weight upon area, W is weight of the liquid. We know weight is equal to rho G into V, where rho is density of this liquid, G is acceleration due to gravity, and V is volume, A is area which is already there. So if we define this volume of the cylinder, then it is equal to height into area. So after cancelling this area with this A, then P is equal to rho GH. This is very important definition or important formula for finding the pressure in terms of height of the liquid, where rho is mass density and G is acceleration due to gravity and H is distance from the surface of that liquid. So atmospheric pressure, with the change in height, the pressure is changing because of height. So P is equal to rho GH. At the sea level, the pressure is 1 atmospheric and it is equal to 101.3 kilopascal, or we can say 1.013 into 10 raised to power 5 Newton per square meter. In the all units, 1 bar is equal to 1 into 10 raised to power 5 Newton per square meter. So with the change in height, the pressure is changing because of the weight. So gauge pressure we will define in the next slides. It is equal to rho GH, where rho is the density of the liquid or the fluid, and G is the acceleration due to gravity, and H is height of the mercury column. So if we use mercury in the column, then rho GH is equal to density of the mercury is 13600, so it is 1.36 into 10 raised to power 4 kilogram per meter cube, and G is acceleration due to gravity, it is 9.8, height is 10 raised to power minus 3 meter. If we take H is equal to 1 mm of mercury, then pressure is equal to 133 Newton per square meter, or 1 Newton per square meter is equal to 1 Pascal. So 133 Pascal, and this atmospheric pressure is equal to 1 torr. Next, I will define how much is a Pascal. We know Newton is a force which is required to accelerate a mass of 1 kilogram at the rate 1 meter per second square, and acceleration due to gravity is 9.8. So force due to gravity on a 1 kg mass is 9.8 Newton, and this force is 1 kilogram weight. So 1 Newton is equal to 0.102 kilogram weight. If we divide this 1 Newton by 1 square meter, that is unit area, then this is equal to 1 Pascal. So now we will define atmospheric pressure. We know atmospheric pressure is due to air because there are different gases in the atmospheric. So we live at the bottom of an ocean of air or gulf of air. Highest pressure occur at lowest altitude because the air is more. Standard atmospheric pressure is the pressure that supports 760 mm column of mercury, or it is equal to 76 centimeter column of mercury. So 1 atmospheric is equal to 760 mm of mercury or 76 centimeter of mercury column. Next, these are very important terms for the pressure measurement. So first I will define what is an absolute pressure. It is measured above the total vacuum or zero absolute. Zero absolute represent total lack of pressure. This is the first term is absolute pressure. Second term is atmospheric pressure. It is the pressure exerted by Earth atmosphere. Atmospheric pressure at the sea level is 1 atmosphere. The value of atmospheric pressure, it decreases with increasing altitude. So, atmospheric pressure totally depends upon altitude and the gases which in the atmosphere. Third one is barometric pressure. It is same as atmospheric pressure, because most of the time we are using mercury for the pressure measurement. Any instrument which measure pressure is called barometer. So, barometer is the term because of bar, unit of pressure. Next term is gauge pressure. It is the pressure above the atmospheric pressure. It represents the positive difference between the measured pressure and the existing atmospheric pressure. It can be converted to absolute by adding the actual atmospheric pressure value. Next one is differential pressure. It is mainly, as from its name, it is mainly difference between the two levels of pressure. So, the difference in magnitude between some pressure value and some reference pressure, that is called differential pressure. In a sense, absolute pressure could be considered as a differential pressure with total vacuum or zero absolute as a reference. Likewise, gauge pressure, which is defined above the atmospheric pressure, it is considered as differential pressure with respect to atmospheric pressure as a reference. So, I think here the terms should be more clear. So, if we are here, if the pressure of a gas is at this point, this is 1 atmospheric, this is atmospheric pressure, and the total pressure of the gas including the atmospheric, this is called absolute pressure. All the instruments measure mostly gauge pressure, which is the above the atmospheric pressure. So, if we add gauge pressure and atmospheric pressure, then it is equal to the absolute pressure of that gas. Or if there is vacuum in the container, then we can easily measure its vacuum. This is called negative gauge, or the pressure is less as compared to the atmospheric pressure. So, the same thing I have defined here. This is the, up to this point, this is the atmospheric pressure. Differential pressure, it is a difference between the 2 points, any 2 levels. Absolute pressure is measured relative to the perfect vacuum. Gauge pressure is measured relative to the ambient pressure. Differential pressure is the difference in pressure between the 2 points of the measurement. Note that the same sensor may be used for any types or any reference, but the reference is different in each case. So, pressure is commonly quoted as being absolute or gauge. An easiest way of thinking is like, if there is some fluid, then there is some pressure which is equal to some absolute pressure. If there is no fluid, then there is no pressure, and which is equal to 0 absolute pressure. Whereas fluid pressure plus some atmospheric pressure is equal to some gauge pressure. If there is no fluid, then only there is atmospheric pressure, then the total of these two is equal to 0 gauge pressure. So, gauge pressure minus atmospheric pressure, it is equal to pressure due to the fluid, or is equal to absolute fluid pressure. So absolute fluid pressure, when measure the tire pressure, we measure the pressure above the atmospheric pressure. So recommended pressure for the tires are the gauge pressure. Absolute pressure, it is a total pressure of all the gases including the atmosphere. So how would you figure it for the inflated tire? If we add the atmospheric pressure or the barometric pressure to the gauge pressure, then it is equal to the total pressure of the gas. So gauge pressure is mainly pressure minus the atmospheric pressure. So now we will define pressure gauge. Gauge means any measurement. A pressure gauge is used for measuring the pressure of a gas or a liquid or any fluid. Vacuum gauge is used to measure the pressure in a vacuum. A compound gauge is used for measuring both the vacuum and pressure. Pressure gauges are used for indication only. So here we define, I have shown some example, like this is the instrument which is used for the measurement of blood pressure. So this is used for tire pressure. Pressure gauge, it is an instrument used to measure pressure inside a tire or oxygen tank. Now we will discuss what are different devices to measure pressure. First one is barometer. It is an instrument that measures pressure which is exerted by the atmosphere. It is invented in 1600 by Torricelli. So it mainly represents the height of column of mercury and it is equal to the atmospheric pressure. So this is the height of mercury column, 760 mm of mercury. Up to which height the mercury rises, that corresponds to the pressure of that liquid. Depending upon formula, P is equal to rho G H. So mercury barometer, we know it is invented by Torricelli and it is used to measure the atmospheric pressure. So the weight of the air pushes down on the mercury in a dish. Inside the glass tube, the weight of the mercury is pulling down P of mercury and the air pressure can support 760 mm of mercury. So this is the basically height of the mercury, up to which level mercury is rising. So based upon that we can find the atmospheric pressure. In the mercury barometer, the atmospheric pressure is directly proportional to the pressure applied on mercury. That is, it depends upon the change in height of the mercury column. If there is some weather disturbance, then this mercury column will increase or decrease instantaneously. So depending upon that, all the meteorological department, they find whether there is change in environment or not, depending upon pressure. So next device which is used to measure pressure is C-type Bourdon tube, a section of tubing that is closed at one end and is partially flattened and coiled. So here we apply here some gas for which we want to measure the pressure. So depending upon the structure of this tube, we will easily find the pressure scale. Here we have put some scale. So depending upon its inflation, we can easily find the pressure here with this scale. So when a pressure is applied here in this the open end, the tube uncoils. This movement, it provides a displacement that is proportional to the applied pressure. So the tube is mechanically linked This tube is mechanically linked to this pointer on a pressure dial to give the calibrated reading. Next is manometer. A mercury manometer is a simple pressure standard and it can be used to measure gauge differential or absolute